Okay, good morning. Welcome to
Counting number 22a.
Counting number 22a. So we're staying in section 5.1, or actually I guess it's 5.2, isn't it?
Yeah.
Today. So we're counting on grids, and we did a few of the problems. And now I'm going to show you something that's really neat, and it's called a combinatorial identity. And we're just going to do it for square grids today, just for fun. So here's my example with the 4x4. We're going to walk from A to B. And we're going to create an expression that is very surprising. And we're going to see that it tells us something new about Pascal's triangle that we didn't know already. Okay? So we did a problem like this. How many paths from A to B go through here? And how did we solve that problem?
Well, we did the number of paths that go from A to that point, and then the number of paths that go from that point to B, and then we multiplied them.
We multiplied them together. Okay. But to go from A to B, you have to pass through some intermediate points, and I'm going to focus on the diagonal.
Yeah.
Okay. So to go from A to B, you have to pass through one of those points, right?
Yeah.
And let me just erase that point just to avoid any confusion. Okay. Does any path go through two of those points?
No.
No, if you're only moving down and to the right.
Yeah, sorry, we probably should have been clear about that in the beginning. You can only move down and to the right. So any path from A to B has to pass through one of those points.
Yeah.
And in fact, can pass only through one of those points. Okay. So how many paths go from A to B? What's the total number of paths?
Doing choosing number method, so we have to take 8 steps to do it.
Yeah.
And we have to choose 4 ways we can go down.
Okay.
So that's 8 choose 4.
All right. Sorry for bumping the camera. So the total paths is 8 choose 4.
Yeah.
All right. And that'll be the middle number on the 8th row. Pascal's triangle.
So.
But how many paths go from A to this point?
Well, there's
I think
there's be only one. This straight across, straight down.
Okay.
Because you can't go up.
All right. So how do we write that as a choosing number?
So
we have 4. We take 4 steps to do it, and we have to choose. We can choose 4. We have to choose 4 going across. 4 steps going across. So there's only one way.
Right. But what is it as a choosing number?
It's 4. It's 4 choose 4.
4 choose 4. Okay. And how about going down?
Going down.
well, from that point to B, that's also 4 choose 4.
Okay. So we multiply 4 choose 4 times 4 choose 4. Right?
Yeah. And wouldn't that?
And that gets us, that gets us the number of paths that go from here, A to this point, and then from this point to A. And in fact, if we wanted to let our choices represent the number of ones across, I would call this one 4 choose 4, and what would I call this one going down?
4 choose
0.
4 choose 0. So if we want to be consistent with our choosing choices, we would call that 4 choose 4 times 4 choose 0. Okay? Now let's complete what it is. That's the paths that go through this point. Now we've got to add in the paths that go through that point, and that point, and that point, and that point, okay?
All right.
Okay.